ISS Fire Station to explore the tops of thunderstorms, presented by Science at NASA. We all know what comes out of the bottom of thunderclouds: bolts of lightning. Jagged columns of light plunge earthward, heating the air to 50,000 degrees Fahrenheit, about 5 times hotter than the surface of the sun. Claps of thunder announce this process somewhere on Earth as often as 50 times a second. Have you ever wondered, though, what comes out of the top? In recent decades, researchers have discovered some strange things happening in the cloud tops. High above ordinary lightning, exotic light flashes known as red sprites, blue elves, and blue jets shoot toward the heavens, cold cousins to the fiery bolts below. In some places, jets of antimatter fly upwards, triggering the detectors on NASA's orbiting high-energy observatories. And, as often as 500 times a day, Earth briefly mimics a supernova, producing a powerful blast of gamma rays known as terrestrial gamma ray flashes, or TGFs. No one knows exactly how these phenomena are related either to each other or to the lightning down below. A new experiment called Fire Station on board the space station aims to find out. Fire Station is a package of sensors designed to explore the links between TGFs, ordinary lightning, and sprites. The space station's orbit will carry Fire Station directly above thousands of active thunderstorms during the 1-year lifetime of the experiment, says Principal Investigator Doug Roland at NASA's Goddard Space Flight Center in Greenbelt, Maryland. The ISS is perfect for this kind of research. Unlike previous experiments in upper atmospheric lightning, Fire Station has the unique ability to observe thunderstorms at multiple wavelengths simultaneously. It can record the radio static from lightning, measure its optical glow, including the red and blue light of sprites, elves, and jets, and detect the gamma rays and electrons associated with TGFs and antimatter events. Roland expects Fire Station to observe up to 50 lightning strokes per day, at least one TGF every few hours, and a large TGF every couple of days. Such a fire hose of multi-wavelength data will allow researchers to sort out cause and effect connections impossible to see in previous studies. There are several different types of lightning, Roland says. At the moment, we don't even know which type produces a gamma ray flash. Fire Station could solve that decades-old mystery in its first few weeks of operation. The thing that intrigues Roland most about TGFs is their surprising energetics. Gamma rays are thought to come from the most violent events in the cosmos, like stars colliding or exploding, he points out. What a surprise to find them shooting out of the cold upper atmosphere of our own planet. Something up there is accelerating low-energy particles of air to nearly the speed of light, producing gamma radiation and sometimes a cascade of antimatter. Roland wants to find out what that strange, unknown something is. Fire Station is poised to crack the mystery. The experiment was delivered to the space station on August 3, 2013, by the Japanese robotic cargo vessel Kounotori 4. It has since been installed on the station's exterior by the station's robotic arm. All of the sensors were checked out at the end of August, and full-time science operations are slated to begin in early September 2013. For results from the cloud tops, stay tuned to science.nasa.gov.